Good day, everyone. I am Sude Zehra Aydın, and currently I am a physics student, first year physics student at Bilkent University. And for my Physics 101 lab report, I have chosen to determine the experimental value of gravitational acceleration by using a simple pendulum. In this experiment, we will basically learn the behaviors of oscillations and also learn a bit of simple harmonic motion. And by doing so, at the end, we will calculate the gravitational acceleration in that particular locale. So let's move on. So in order to understand the results that we will get from the experiment, firstly, I want you to get to know the background of this experiment a little bit better. In order to do so, we have to understand why we are using a simple pendulum in this specific experiment. And the reason of it becomes from the behavior of simple harmonic motion. And the definition of simple harmonic motion is basically a motion in which the restoring force is directly related to the distance the body is from its equilibrium position. And a simple pendulum performs simple harmonic motion with a period that is directly proportional to the length of the pendulum string and inversely proportional to the gravitational acceleration of the locale. And the equation we will use in this experiment is the periodical formula of a simple pendulum, in which you can see at the bottom of this page. And to get g alone and out of this equation, we firstly have to take the square of the equation, in which we get t squared is equal to 4 pi squared times L over g. And then when we solve for g in this specific equation, we get g equals to 4 pi squared times L over t squared. And the equation we will use is, as you see, the figure 1.4, in which L is the length of the string of the pendulum, and t is the period of oscillations, and g is the gravitational acceleration. In order to set the experiment up, we have some required instruments. In some cases, these instruments can change. However, you will get the basic idea of the experiment setup from the photograph here. And the required instruments goes as a laboratory post and clamp in order to hold the pendulum. And also we need a thin, inextensible string to carry the mass. And also we need a pendulum bob for mass at the string's end. And fourthly, we need a metric tape measure to measure the string's length. And lastly, we need a video recorder for capturing oscillations accurately to measure time. Now, in order to move on with our experiment, we need to know the steps that are involved. Firstly, we need to set up the apparatus, attach the pendulum to a fixed support using the clamp and ensure that it hangs freely. And then we need to measure the string length. Use the tape measure to determine the length of the string, L, from the clamp to the center of the bob, in which case I have a picture of me doing so. Then you need to release the pendulum. However, you need to pull the pendulum to one side at a small angle and release it without applying any push. A small angle ensures the simple harmonic motion behavior. That is the reason why I have chosen 10 degrees to be more accurate. And then you need to record the motion. Use the video recorder to capture the pendulum swinging for, in this case, I have chosen 20 oscillations. And note the total time taken and divide this by 20 to find the average of periods, which is t. Then I have repeated the experiment in 5 trials, varying the length of the string each time, and record my measurements for both length and the period of the simple pendulum. And then by concluding our 5 trials, I have both taken the average of the string length and then the period. As you can see from this table, as I said, I have taken 5 trials of information both for the length of the inextensible string and for the period of the pendulum. And when I took the average of those values, my average length of the inextensible string was 0.2 meters and my average period of the pendulum was 0.9 seconds. If we go back and recall our equation as g equals 4 pi squared L divided by t squared, we will put our average length value and our average period value in this equation. And at last, when we put our average length of inextensible string and average period of the pendulum results to the said equation, we get the experimental value of g as 9.7 meter per second squared. And we have taken the actual value of g as 9.8 meter per square, which makes the percentage error of our calculation as 1%. And even though we have reached into a quite accurate and precise calculation, we still need to acknowledge why we have that 1% of uncertainty. And in this case, the errors came from the first and foremost, the human error itself, and also secondly, the simple harmonic period equation for a simple pendulum actually assumes that there is no air resistance in that particular locale. In our case, it is impossible to create an environment in which we can neglect air resistance. Thus, we have some errors in our calculations due to this fact. In conclusion, this experiment is a practical demonstration of how a simple pendulum can be used to measure gravitational acceleration with precision. It basically highlights the direct relationship between the period and the string length, as well as the inverse dependence on gravitational acceleration. And by the end of this experiment, we have a deeper appreciation of the interplay between theoretical physics and practical measurements. At last, this was my report on determining the gravitational acceleration by using a simple pendulum. I hope this explanation clarifies the experiment. Thank you for listening.